So, hello everyone. Today we are going to discuss one of the most important concept in computer graphics, that is shading, and various shading techniques like flat shading, Gouraud shading, and Phong shading. So, shading is very crucial concept in computer graphics that we use in various areas of modern application like 3D graphics, photorealistic renders to stylized animation, and so on. So, the first first technique we use in computer graphics is flat shading. It is the most basic form of shading as we know, and key concept here is as we use single pixel or single point on surface to color or shade entire surface, and it requires very less computational power. But problem is with flat shading is it lacks realism and smoothness, as we cannot shade the curved surfaces like circle, cylinder, etc, etc. So to tackle this, we have more advanced shading techniques like first one is Gouraud shading. In Gouraud shading, the key concept is we use interpolation, interpolating intensity values at vertices to shade the entire surface. So in Gouraud shading, we get more smoothness, a gradual transition as compared to flat shading, and it can be used to shade various rounded or curved surfaces like sphere, cylinder, as we seen in previous slide. So how it works? It works by interpolating the intensity values at vertices. By interpolation we mean approximation or estimation of new values based on known values. So we estimate the intensity values in between the two known values of intensities between two vertices. So here it is the technique to find the normal vector. So this is the better way to understand how it works. So we have scan line, and suppose this is the polygon surface, and we know intensity values at vertices, that is 1, 2 and 3. So scan line will move upwards here in this case, and we know the intensity values at 2 and 1 and 2, and we will interpolate intensity values at 1 and 2 to find the intensity at, or to interpolate intensity at 4, and we'll use vertex 2 and vertex 3, which will be here, to find the intensity value at 5 using this formula. We will use this formula to determine the intensity values at 4 and 5, and when we will get intensity values at 4 and 5, we will use same formula to determine intensity value at P, point P, and using point P we will shade the entire surface, and this will give more realistic, smooth and gradual appearance as compared to flat shading. So this was the key concept, and this is the key formula here. Next is Phong shading. Phong shading is more advanced, more realistic, and gives more smooth appearance as compared to Gouraud shading, but it also requires more computational power. We can say it is the most advanced shading technique between the three. It can also give more accurate reflection and highlights. So how Phong shading works? So in Gouraud shading we use interpolation of intensity values at vertices, but in Phong shading key concept is we will use interpolation of normal vectors at the each surface. So that is the difference between two. Both are the interpolation techniques. So you can read here the Phong shading normal themselves are interpolated across polygon, producing a smoother shading effect. Hmm. Also, now for each vertex is calculated, and for each scan line in normal vectors are linearly interpolated at the endpoints. So you can read this, and it is the actual implementation. Similar to that of Gouraud shading, we will find the normal vectors like this formula, but the difference here is we will interpolate the normal vectors. If we want to find the intensity, this normal vector, we will use known normal vectors like n2, n1 and n2. We will interpolate this. Concept is same, but formula will be little different as we are interpolating normal vectors. So this will give you the intensity value. So when we compare both the shading techniques, we get that Gouraud shading produces smoother, more continuous transition between the faces with less visible fetching. But the advantage with Phong shading is that we can shade the surfaces with abrupt change or more intense change between the two intensity values. Gouraud shading cannot handle that. It also gives more accurate view of lightning or reflections, but Gouraud shading cannot give it. So computational cost will obviously be more for Phong shading as we are interpolating the normals, but in Gouraud shading it is less. So application sustainability wise, Gouraud shading is well suited for real-time rendering, as it will bring down the cost or computational cost, while Phong shading will useful for high quality imagery or where we need where we don't have any restrictions of computational cost. So this is the difference between two images. On the left is Gouraud shading and on the right is Phong shading. We can clearly see the main differences between the reflection and smooth transition. Phong shading is always better. So advantages of Gouraud shading is computational efficiency. As we seen in previous slide, Gouraud shading is less computationally intensive algorithm compared to Phong shading. Also, Gouraud shading gives smooth appearance. Only disadvantage is it cannot handle the abrupt change in intensities. Reduced memory footprint. It also counts in computational cost, like Gouraud shading only requires storing vertex normals. It reduces the memory requirements compared to Phong shading. Gouraud shading is, yes, quite simpler as compared to Phong shading. So these are the advantages of Phong shading. Phong shading is more realistic and it can create more accurate reflections as we seen in this image. It can clearly form better reflection and better appearance. So second is Phong shading. Second advantage of Phong shading is a smooth gradient. Phong shading interpolate normal across the surface, resulting in smooth transition between light and dark areas. It can handle more abrupt change. It can give better appearance as compared to Phong shading. Also, third advantage is flexibility. Phong shading can give better image when we have complex structures, complex diagrams, complex polygons, complex organic shapes. So Phong shading is better in these terms. In real-time capabilities, advanced in graphics hardware have made fast enough for real-time application. Like we know today, the computers, mobiles, etc. are getting faster and faster in processing. So it will be more beneficial to create more smoother surfaces. So that's for today. Thank you.